This is the mid-module assessment review for Module 5, starting with number 1. Joel has a bowl containing 4 red, 2 orange, 4 yellow, and 10 green mints. What is the simple probability of the mint being orange? We have a total of 20 mints, 20 of them being the total, 2 of them being orange. Simplifying that is 1/10. So the answer here is A. The second question. I will get the hang of this, guys, by the end of the year, I promise. Mark placed 6 blue tiles and 4 red tiles in a container. He plans to draw a tile, record its color, and replace it in the container before drawing another. Suppose Mark does this 50 times. How many times should he expect to draw a red tile? Well, if we do this, we should have 4. The probability is 4 out of 10 times the amount of times that he is going to be drawing this, which is 50. Okay. So by simplifying this, 10 goes into 50 5 times. So 4 times 5 is 20 times. So the answer to this is C. For number 3, there are 5 appetizers, 6 main dishes, and 2 desserts on the menu. How many different combinations can John make if he chooses 1 appetizer, 1 main dish, and 1 dessert? You can use the fundamental counting principle here by multiplying 5 times 6 times 2, which will give you 60 different combinations, or the letter A. Okay. Next, Leanne collects data throughout the basketball season and uses these data to determine the probabilities of different teams playing in the league championship game. The probabilities for her 4 favorite teams playing in the championship game are shown below. You can do a couple of different things here. Change them to decimals, percents, the same for denominator, however you'd like. I changed them to decimals. This one would be 0.67. This one would be 0.80. This one would round to 0.38. This one would be 0.50. It says which of these teams is least likely to play in the championship game, and that would be the Bulldogs, or choice C. For number 5, which event is most likely to occur? Flipping a fair coin with sides labeled heads and tails, and the coin landing on tails is 50%. Choosing a marble out of a bag with 9 blue marbles and 1 red, and landing and pulling the red marble would be 10%. A fair number cube, landing 1 to 6, numbering 1 to 6, and the cube landing on a number less than 6 is 5/6, or 83%. And spinning an arrow on a spinner with 4 equal sectors, 1 to 4, and an arrow landing on a number greater than 1 is 75%. So your answer here would be C, for it being the most likely to occur. As we did these in class today, to have these as a fraction, decimal, and percent. for pulling purple would be 3 out of 30, or 1/10 would be 0.1 and 10%. Next would be blue, would be 6 out of 30, 1/5, 0.2, or 20%. For the third one, orange or blue, let me move this up. For orange or blue would be 7 plus 6 out of 30, or 13 out of 30, which would be 0.4, 3 repeating, and it would be 43 and 1/3%. For not purple would be 27 out of 30. Remember to add them. So let me change this. For not purple would be 7 plus 6 plus 14, which is 27 over 30, or 9 out of 10, which is 0.9, or 90%. The probability of white is 0 out of 30, or 0, 0.0, and 100, or sorry, 0%. The probability of a marble is 30 out of 30, which is 1, or 1.0, which is 100%. For number 7, draw a tree diagram. Sam wants to order an ice cream with toppings. He can choose from either chocolate, vanilla, or strawberry, along with 1 topping from sprinkles or peanuts. So the first one is the flavor. So chocolate, vanilla, or strawberry. Next is the topping. So sprinkles or peanuts, sprinkles or peanuts, sprinkles or peanuts. So the different outcomes. Would be chocolate and sprinkles, chocolate and peanuts, vanilla and sprinkles, vanilla and peanuts, strawberry and sprinkles, strawberry and peanuts. So now to find the probability of vanilla and sprinkles would be 1/6. Each student in a class of 28 was asked to report how many siblings, brothers and sisters, he or she has. The data are summarized in the table below. First, let's count to make sure there are 28, and we did that in class. It says, based on the data, estimate the probability that a randomly selected student from this class is an only child. So the probability of 0 is 4 out of 28, or 1/7. Based on the data estimate, The probability that a randomly selected student from this class has 3 or more. Probability greater than or equal to 3 would be 3 plus 0. Because 4 is one of those answers. Plus 2 plus 1 out of 28 would be 6 over 28 or 3 over 14. Next answer, or the next question. Based on the data, estimate the probability that a randomly selected student from this class has less than 3 siblings. So the probability of less than 3 would be 4 plus 12 plus 6 over 28, which would be 22 over 28, which would be 11 over 14. And the last one, based on the data, estimate the probability that a randomly selected student from this class does not have 2 siblings. So the probability of not 2. So that would be 28 over 28 minus 6 over 28, which would be 22 over 28 or 11 over 14. Next. Okay. In the game of darts, players throw darts at a circle divided into 20 wedges. In one variation of the game, the score for a throw is equal to the wedge number that the dart hits. So if the dart hits anywhere in the 20 wedge, you earn 20 points for that throw. If you are equally likely to land in any wedge, what is the probability that when you throw one dart, you will score 19 points? Probability of 19 is 1 out of 20. If you are equally likely to land in any wedge, what is the probability that when you throw one dart, you will land in the lower right? That would be 5 out of 20. Because if you land in the lower right, you would score 3, 17, 2, 15, or 10. And that would be simplified to 1/4. Below are the results of 100 throws for one player. Does this player appear to have a tendency to land in the lower right more often than we would expect, less often than we would expect, or exactly what we would expect if the player was equally likely to land in any wedge? Show your work to justify your answer. Well, the probability to land in that lower left would be in the lower right would be 1/4 times the 100. So that would be 25 times is what we would expect. So now if I count up the times, for to land on 3 would be 2, to land on 17 would be 4. They landed on 2, 9, on 15, 5, and on 10, 7. So we have 9 plus 2 plus 7 plus 5 plus 4. And that all equals 27. So the prediction was lower than the actual data. Next, a bag contains 2 black marbles, 6 white marbles, and 2 red marbles. The faces of a die show the numbers 1 through 6. Find the probability of drawing a white marble and tossing a 2. So a white marble would be 6 out of 10 times 1 out of 6. I can cross off the 6's, and that would equal 1/10. Okay. There are 3 oranges, 6 bananas, and 4 apples in a fruit basket. Bella selects a piece of fruit at random, and then Terry selects a piece of fruit at random. What's the probability that 2 bananas would be chosen? So 6 bananas out of 13 times 5 bananas out of 12. So I simplify to get 5 bananas out of 26. Okay. Last, sorry, my lights again went out. I always do this. Sorry, guys. This last problem, student purchases a bag of 24 mini chocolate chip cookies, and after opening the bag, finds 2 cookies that do not contain any chocolate chips. The student then wonders how unlikely it is to randomly find a cookie with no chocolate chips for this brand. Based on the bag of 24 cookies, estimate the probability of this company producing a cookie with no chocolate chips. Well, that probability of no chocolate chip would be 2 out of 24, or 1/12. Then explain how you could simulate how you could simulate randomly selecting 24 cookies, one bag from such a population, to determine how many of the sampled cookies do not contain chocolate chips. Explain the details of your method so it could be carried out by another person. Okay. So the 2 outcomes are chips or no chips. We could use picking a cube out of a bag. 22 red cubes would represent chips Sorry, cookies with chips. Two blue chips, cubes, sorry. Would represent cookies with no chips. With no chocolate chips. Pick a cube out of the bag. Record it. And replace it in the bag. Do this 24 times. A success is pulling a blue cube.